So example 1, we're dealing with ones where we have repetition. And remember when I told you if I stood up here and I put like 3 of the exact same black cars in a row standing in front of you here, and then I moved those 3 cars around and I'd say, does it look different? You'd say no, right? So if I had 3 of the exact same black cars and 1 red car, this would look the exact same as if I took these 3 cars and dispersed them, right? It would still look the same, or I moved them around. You'd still have 3 of the exact same black cars and a red car, 3 of the exact same black cars and a red car. So those cases would look the exact same when we have repetition, correct? So we have to find out a way to get rid of that issue, to get rid of where they would actually look the exact same. And how can we do that? Well, what you do is you just divide by the factorial of the ways that there are repetitions. So you treat the top as if they totally look different, just like we have done so far, and then all you do is you divide by factorial. So if there was 3 green cars that looked exactly the same, I'd go 3 factorial, I'd divide that by 3 factorial, and it would get rid of all the cases where they actually do look the same, right? So I treat the top like they're totally different, divided by the factorial of the bottom. So we're going to look at example 1 here for a second and see if this can make some sense. In the mountainous regions of India, China, Nepal, and Bhutan, it is common to see prayer flags. Each flag has a prayer written on it, and color is used to symbolize different elements: green for water, yellow for earth, white for air, wind, blue for sky, space, and red for fire. Now, if I have 2 blue flags, can you tell the difference between them? No. If I had 7 white flags, could you tell the difference between them? So if I put 7 white flags in a blue one, and then I move these 7 white flags in a blue one, it would look the exact same, correct? It would, because there's repetition. So we have to watch for repetition. So here it says, how many different arrangements of the same prayer, so same prayer would mean like white, blue, blue, like it looks the exact same, from all 9 flags. Which of these 9 flags, there was 1 green, there's 1 yellow, there's 2 white, which I can't tell apart. There's 3 blue, which I cannot tell apart, and there's 2 red, which I cannot tell apart. Okay? So the moment you have repetition, what we're going to do is we're going to divide by that repetition. So in the denominator, I'm going to immediately put 2 factorial for the 2 white flags, 3 factorial for the 3 blue flags, and 2 factorial for the 2 red flags. And that's going to get rid of the cases where 2 reds, and I flip the 2 reds, looks exactly the same. Okay? So when you have repetition, you immediately make yourself a denominator with the factorials. So you have to spot repetition. So when it said like same model of car, which we've never had yet, same model of car would mean they would look the exact same. Repetition, you need to divide by factorials. So we have 9 flags. Does it say I have to start with a white or end with a blue or anything like that? Nope, so I have 9 flags. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I treat them like they're all different on the top, because the bottom, those factorials, get rid of the cases where they actually are the same. Okay? So that first blank, how many flag options do I have? How many different options of flags could I put here? What does it say for a total? 9. Someone whisper answered 9. You were right. It says 9. Do I care that 2 of them are white, and if I had a white here and a white here, it would look the same? No, because the factorials on the bottom are getting rid of the cases where they would be the same, right? So 9 flags, leave a flag. Then what? 8, then I leave a flag. 7, 6, 5 flags left. 4, 3, 2, 1. So on the top I have 9 factorial, and on the bottom I have 2 factorial, 3 factorial, 2 factorial. Now, if you have a TI-83 calculator in your hands, you will have to make sure that your denominator is in brackets. If not, your calculator is order of operations. It's going to go 9 factorial divided by 2 factorial. Take that answer, multiply by 3 factorial. Take that answer, multiply it by 2 factorial. That's not what we want, right? We want 9 factorial divided by all of those, so you have to put them in brackets. If you have the new calculators, you will use the fraction button. So you're going to go alpha, y equals, enter. And you won't have to worry about brackets. 9 factorial divided by 2 factorial. Do I need the factorial if it's a 2? No, because 2 factorial is 2. 2 factorial, and then 3 factorial, 2 factorial? Was that what it was? So I don't need brackets if I'm actually using the fraction button. But watch if I don't, if I have a TI-83 or I don't use the fraction button. Watch what happens. So that's the actual answer. 9 math factorial. That's not factorial. 9 math factorial divided by 2. What do you think it's going to do? It's going to go 9 divided by 2. Take that answer times by 3. Take that answer times by 2 because it does order of operations. Is that the right answer? No. So you need to make sure you put brackets around that denominator if you have the fancy ones. Or just use your fraction button and brackets aren't needed, right? So it's 15,120. Now guys, that's the result. And it's gotten a lot smaller because there are cases where if I flip-flop those same ones, it gets me the same answer, right? If all of those were different colors, my answer would be 9 factorial. Ugh. There would actually be 362,880 different prayers we could make. But because there's repetition where they would look the exact same, it actually knocks us down to 15,120 different prayers. So when you have repetition, your answer will drop down. If you forget to divide by the repetitions, do you think they'll have that answer there on the test? Yes, they absolutely will. If you forget to divide by the factorials, the answer will be there. Often picks more than the correct one, which is just said. So this here says the number of permutations of n objects where A are the same of one type, B are the same of another, C are the same of yet another type can be written in this expression. So what do? You treat the top like it's totally different, and then divide by the factorials at the bottom. Okay? We haven't had to worry about words before because words before have never been repetitious, so I didn't make you do anything. But what I'm going to tell you right now is whenever you get a word, what you need to do is rewrite the word and stack the letters if they repeat. Okay? So, we're going to go like this. V, A, N, C, O, U. Oh, I have a repeater, so I'm going to go V, E, R. Now, the reason why I stack the letters is twofold. I stack the letters so it reminds me to divide by the factorial. Because if I'm stacking them, I'm like, why am I doing this? Just for fun? And I'm like, right, I need to divide by the factorial. So it gives you like a hint to do that. Secondly, you often won't miss the doubles or triples if you actually write them back up. Okay? So Vancouver has 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there any restrictions on this? Like I have to start with a B or end with a D? D? There's no D's in Vancouver. Vancouver, you know that one? There's no restrictions. So on the top, I would have 9 blanks, and I'd go 9, 8, 7, 6, 5, 4, 3, 2, 1. Blast off, correct? So on the top, I would have 9 factorial, because there are 9 letters in Vancouver. And on the bottom, what would I have? 2 factorial. And that's it. So if Vancouver didn't have any doubling or tripling letters, I would have 362,880. But because it does, I actually have half. I have 181,440. Mathematical. This one has a lot more letters, right? That double and triple, so let's write it out. The people who never succumb to stacking letters and rewriting out the word are the ones who get this question wrong all the time because they'll forget to divide by factorials. So please humor me and do as I do. So M-A-T-H-E-M-A-T-I-C-A-L. So how many letters are in mathematical? What do you get? Slightly painful. 12, yes. 12 factorial, because you would have 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, because there is nothing restricting it. Make sure your phones are away. Okay. In the bottom, because I'm stacking for a good reason, not no apparent reason, I'm going to write 2 factorial for the 2 M's, just like they did with the prayer flags, right? 3 factorial for the A's, and 2 factorial for the t's. Everyone type it in. I got 19,958,400. Different words I can make out of mathematical. And it actually is downsized, because if mathematical had 12 letters that were all different, it would be 12 factorial, which is actually substantially bigger. Okay? Wouldn't that be nice if that's how they go? But what happens is they might give you some restrictions, just like we did. We've done all of these. We did words. You just did homework with it, where you did words where you had to keep these letters together or whatever, right? The only difference is if there's repetitions, you divide by the factorials. That's the only way it makes it different, honestly. So here it says, determine the number of different arrangements of the 6 letters in the word answer. So I go A, N, S, W, E, R. Wait a second, I just rewrote the word. If I just rewrite the word, I have no denominator, right? Perfect. Now, without any restrictions, how many different words could I make from answer? I would have 6 letters for this one, box and hold. 5 letters for this one, box and hold. 4, 3, 2, 1, which is 6 factorial, which is 720. Nothing new there. Then it says that begins with an S. So we still have 6 letters. Begins with an S. How many S's are an answer? 1. Then how many letters do I have left? And 4, 3, 2, 1. So it's just 5 factorial, or 120. Begins with a vowel and ends with a consonant. How many vowels are an answer? A, E, I, O, U. There are 2. We have an A and an E. So we have 2. Then we can box and hold one of them. This is if you want to show all the work. Consonants, we have N, S, W, R, which is 4. Let's hold the N. How many letters have I used up? 2. How many do I have left? 4, 3, 2, 1. 192. Okay, then we're flipping over. Now, that has 3 letters, A and S adjacent. We were just doing these, right? We were literally just doing these. 1, 2, 3, 4, 5, 6. Adjacent means together. Does it say in a specific order? In the order A and S. This is directly from the homework you just did, correct? So I would have one option, it has to be an A. One option has to be an S. One option, or it has to be an N. One option has to be an S. Used up 3 letters. 3, 2, 1. Am I done? No, I have to multiply by 4 because there's 4 places to move it. And so I get 24. Now this one says that have 3 letters A and S adjacent but not necessarily in that order. So now instead of 1, 1, 1, I have 3, 2, 1 for the A and S. 3, 2, 1 for the ones that are left, and I still multiply by 4. That's 24 times 6, which is 144. Cool. That's from your homework. Now, yep. Now this one, here's a difference. Now I have the word and sweet. I don't think it's actually a word. I just wanted to draw doubling letters, so I put an extra A and took out the R. That is what happened in this mathematical concept. Okay, when I was making the notes, I was like, I'm in double letter. And sweet it is. So, we still take the word and we rewrite it. A-N-S-W-E-A. Oh my goodness. There are two A's. Shocking. So this is going to be divided by 2 factorial. This is going to be divided by 2 factorial. I feel like Oprah. You get a car. You get a car. So you just get math. Yay. This is divided by 2 factorial. Oh, wait, there's more. This is divided by 2 factorial. Like, I'm not using any brain matter. Do you see that? No brain matter needed. None. Fresh out of brain matter. Because the moment I have doubling letters, every single thing, people are like, but what happens when do we not use the 2 factorial? Never. If you have doubling things, you will just divide by them. Don't, like, overthink it. Okay? I did it. I didn't even read what the questions were. I just put 2 factorials because I will. Now I'm going to read the questions. It says without restrictions. So without restrictions, I have 6 blanks. 1, 2, 3, 4, 5, 6. How many letters options do I have for this? How many letters are there? 6. Then 4, 3, 2, 1. So now it's 6 factorial divided by 2 factorial, because the 2 factorial is getting rid of all the cases where the A's actually look the same, right? Whereas in answer I didn't have that problem. So it's 360. Begin with an S. One, 5, 4, 3, 2, 1. So last time it was 5 factorial. Well, we're dividing by 2 factorial. It's getting rid of all those A's that look the same. So it's 60. Begins with a vowel. And so the same questions here, right? The catch, though, is this one has how many vowels now? I ruined it for you. It has 3 vowels. So we can start with 3 vowels. It has 3 consonants, so we can end with 3. We've used up how many letters? 2. How many are left for blanks? 4, 3, 2, 1. So 3 times 3 is 9, times 4 factorial, divided by 2 factorial. It's 12 times 9. Oh, no, wait. And then this one's that same thing that have 3 letters. Now watch. I gave this one specifically because it says ANS in that order. But what do you have to watch yourself for? How many A's are there this time? There are 2. How many N's? 1. How many S's? 1. How many letters have I used up? 3. So I have 3, 2, 1. So it's 6. And you're done for today.